Okay, that just kind of cut out. I had to make more room on my laptop to hold the video, so I apologize for that. I think we were in the middle of this problem is when I noticed. Hopefully that's when we were in the middle of this problem. So I did the 75, I got the 3 times 5 times 5. I put those values, I expanded all the x's, all the y's, and the z's, which led me to bring out the single 5. I have x squared because I could take 2 x's out, a y, and a single z, and then I was left with the 3 and the y would be underneath the radical. Okay, that'd be like saying 25 times 3, that's where I get the 75. This would be like saying x to the 4th. This would like be saying y squared, and another y, that gives me the y to the 3rd, and this z is like saying z squared. So that's how that works back to our original. Now this one, I'm pretty sure we went over in class, but just in case we didn't, somehow I missed it, I want to make sure that you know what to do here. So when I am rationalizing the denominator, right, this is a rational, and this is a denominator. So it's a fancy way of saying we got to get rid of this, can't have that. You can't have an irrational number in your denominator. So let's pretend I had 3 over 3. We all know that equals 1. So if I want to clear out this right here, I could say, well, square root of 7 over square root of 7 equals 1, right? Also, square root of 7 times the square root of 7 would be like saying square root of 49, which equals 7, right? So if I multiply both of these by the same number, and I can clear this out and make it a whole value, then I would have rationalized the denominator. So I'm going to take this 4 over square root of 7. I'm going to multiply both the numerator and the denominator by square root of 7, right? So it's basically like multiplying it by 1, but when I work across, I get 4 square root 7. And when I work across here, now I have just a regular old 7. So that would be my answer. 4 square root 7 over 7. Okay, so the long and short of this is I cannot have this here. It's another one of those rules you can't break in math. So in order to get rid of this, kind of like when we would clear fractions, I'm going to multiply the numerator and denominator both by this square root of 7, because square root of 7 times square root of 7 is 7, right? 4 times square root of 7 is just going to be 4 square root of 7. So now I have this here, everybody's happy, and that is the answer for this type of problem. There will be something similar on your assessment, and it is as simple as multiplying the numerator and denominator by whatever this denominator is. That forces this into a whole number, and then you just have now the radicals with the numerator, and everybody in the math world seems perfectly fine with that. Okay, I will be back Friday, so if I didn't see you Wednesday or Thursday, I will answer any and all questions before you guys take the assessment on Friday. Again, I'm so sorry for missing so much class. All right, thank you.